Welcome friends. In our last session, we were discussing about concept of overbooking. We know that there are chances of no shows in various service systems. Passengers may book their tickets in advance, but may not come at the time of actual service. And similarly, in many other cases, there need to be a concept of overbooking, so that you can minimize losses, or in other words you can maximize the revenue generation from your limited capacity. Now, whenever we are doing the overbooking, it is always a risk that all the customers who have booked for that service, if they all come, or if they not come, means customers who actually come for availing the service, they are more than the capacity of the server, then there will be some kind of risk also. And therefore, in our last session, we discussed that in that case, if more customers are coming than the capacity, you will not be able to give service to some of them. You are going to deny service. Denial may be voluntarily, denial may be involuntarily. But whether it is voluntary denial, involuntary denial, there will be some cost you are going to incur. So, there is a cost of denial and there is a possibility of some revenue if you are going for extra booking, overbooking. So, obviously, a very simple issue is that you are going to book any additional seat, if by booking the additional seat, the expected revenue is more than the cost of denial of the service. If the cost of denial is higher, you should not book the services in over. Now, for that purpose, we discussed in our last session that there are different types of policies under which you can think of overbooking. Because the question is, if your capacity is capital C, how much over you should book? And therefore, we discussed that four possible ways are there. One is the deterministic way of overbooking. We discussed with the help of one example in our last session. Then two very interesting policies are there. One is risk based policy and another is service level based policy. And then we are also having a hybrid policy which is combining the risk based and service level policy. Deterministic heuristic, we discussed that you have a historical data, and based on that historical data you are knowing that okay, out of all the customers who are booking your service, let us say 80% are actually appearing, 90% are appearing, whatever is the historical trend you have, accordingly you will decide for overbooking. Here we discussed a parameter rho, that is the show rate. So, how many customers are actually appearing, that is going to decide the overbooking amount. So, based on your historical data, you should see that what is so generally hotels, airlines and various other car rental companies, etc., they have the data. Like in the airlines, it is mentioned in various research papers that generally the show rate is between 85 to 90%. So, around 10 to 15% of passengers are not coming at the time of flight. So, taking the advantage in the most simplest manner, large number of organizations are doing the overbooking using this simple deterministic heuristic. So, here the basic aspect is that we have a deterministic approach where we have the well defined show rate, and based on that we discussed one example in our last session also. Now, in this particular session we will be focusing more on this risk based policy, where we have this understanding that doing overbooking may involve some kind of risk, because you have to estimate the cost of denied service and then you have to weigh these things with respect to potential revenue. So, if potential revenue by doing the overbooking is more than the cost of denial the service, the overbooking is justified. And we will see that how we can develop a decision making rule in the case of risk based policies based on these two important parameters. And if the cost of denied service is more, we will not go for the overbooking in such scenarios. The other important approach we already discussed in our previous class, that is the service level policy. Like in our inventory management classes etc., also we have discussed that a very important aspect is we want to give maximum service to our customers. So, it involves managing to a specific target, for example, targeting that no more than one instance of denied service for every 5,000 customers who are coming to take the service. The meaning is if every time I am having the capacity C doing the booking B, and out of B X are appearing. C is the capacity, B is the booking, and X is the those who are showing. Now, for example, companies generally follow this service level policy in terms of Six Sigma, that whether we are able to maintain a Six Sigma policy with respect to denied services, that only 3.4 customers are denied service out of sufficient number, large number of customers who are appearing for availing your service, or you may have a particular target based on the industry standards also. So, you are a very high level service organization, and then a hybrid policy where we are also looking to balance our cost of denied service and possible revenue, and at the same time we are also looking to provide high service level to the customers who are actually appearing for benefiting the services. So, these are the four different types of policies. I already mentioned that deterministic heuristic is the simplest one and most used one also, but in that case we are ignoring the service level issues, we are ignoring the cost benefit issues also. So, coming to this risk based policy. So, under that risk based policy, the booking limit is set by balancing the expected cost of denied service. You may remember that we are calling this expected cost of denied service as capital D, which you may recall is sum total of different types of benefits you are giving to those to whom we are denying the service. For example, either you are giving a voucher for hotel stay, you are giving a ticket in the next flight also, there may be a loss of goodwill also. So, all these are put together is your cost of denied service with the potential additional contribution from more sales. So, contribution is generally the fare, that is P, the cost is D. So, we are going to balance these two important things, that how much additional contribution you may get by overbooking and what will be the possible in case you are going to deny the service to this overbooked customer, what will be the cost of that. So, cost of denied services, we may have different examples for different types of cases, like a very interesting term we get, that is the concept of gapping, that is actually applicable in the case of broadcasters. Now, this gapping, this concept is basically that you are giving guarantee to your customers that you will get these many number of impressions if you put your advertisement in one of my television program or in one of my let us say electronic program. Now, maybe because of some reason your customer is not getting that number of impressions in one program, then you provide this guarantee that I will continue your advertisements till you get your guaranteed impressions, and for that purpose he means you have to carry forward that particular advertisement for one or two more programs till you provide sufficient or guaranteed number of impression to your customer. So, this is the phenomena that when you are carrying forward the same advertisement for fulfilling the requirement of minimum number of impressions, that is known as gapping in the media industry. So, that is one example that is going in the case of cost of denied service, and similarly in the field of rental car and every like airlines, hotels, etc., we have the examples of cost of denied services. Now, how this function will be calculated for developing that balance between the benefit or the revenue and the cost you are going to incur in this particular case. Now, for that purpose, to calculate a risk based booking limit, we need to specify the objective function, that is denoting the number of passengers who are showing up at departure by S. So, S number of customers are actually physically available at the time of departure of a particular flight. The number of shows, these are in a random variable that depends on both the booking limit and the total demand for the booking. Now, each customer who is actually, we are assuming that only those customers who are appearing for actually taking the service, they only pay you. So, each customer who is appearing is paying you a price of P. So, total revenue will come P into S. This is the total revenue because S customers are coming and P is the price. Now, if shows exceed capacity, if capacity is your C, then the supplier must deny services to S minus C passengers. S is more than C. So, S minus C customers will not be given the services. Now, each customer denied will result a cost of capital D. So, the total cost of denial, the total denied boarding cost is 0 if S is less than equals to C, because in that case there is no overbooking, you will not deny any customer. But if S is more than C, in this particular case D into number of customers denied boarding, this is D cost of denial into number of denied customers. So, D into S minus capital C, that is our cost of denied boarding, denied services. So, the net revenue in this case, that is R, that is the net revenue, P S is the total revenue, and this is cost of denied boarding. Here you see that we have used plus subscript, that the value of D into S minus C can be either some positive or 0. It cannot go into the negative, because S minus C is the number of denied customers. So, otherwise if S is less than C, if S is less than C, this factor will come into some negative thing, and then it becomes PS plus D into that factor, but there is no meaning of negative value of this. So, only the positive value or the 0 value will be considered for this cost of denied services. So, if it is there, it is some positive, otherwise it will not be there. Now, after understanding this net revenue function for the risk based objective function, let us consider the case that I am going to book B seats and I want to see that I want to have one additional seat. Let us consider this one additional seat is a overbooked seat. Now, there are two possibilities broadly, that D, small d is the demand. Now, if small d is more than B, this additional seat will be used, but if small d is less than equals to B, then this additional seat will not be used. So, in that case if additional seat is not used, there will be no marginal impact. You will not get any additional revenue and there will be no cost of denial. So, this is no effect in this case, and the probability of this is given by this FB probability. If I read this FB, it says that this is the probability that demand will be either B or less than B. Demand will be more than B, will be having the probability of 1 minus FB. So, that is the probability that demand is more than B. This is statement, demand is more than B, this is probability of 1 minus FB. Now, when demand is more than B, what is going to happen? Then there are further two situations possible. Situation number 1, that X is greater than B minus C. C is the capacity of our system, B is the booking you are expecting. So, this additional booking is going to give you a revenue of P items. The revenue of P is the price that you will get if X is B minus C. Other case is X is less than B minus C, X is less than B minus C. Now, in this case you have to deny somebody the booking. Now, in this case the revenue with for this additional customer is coming as P, and then because you are denying somebody, the cost of denial the service will also come into the picture, P minus D, and generally D is more, generally D is more than P. So, basically this is loss, this term is representing basically the loss P minus D. Otherwise, just by visual inspection may not look that it is a loss, rather you may see that the benefit is less than P, but actually D is more than P. So, therefore, this outcome of this term will be negative and that indicates loss. So, if D is more than B, if D is more than B, there may be two possibilities. Either you have the benefit of extra revenue that is coming as P, or if you are exceeding your capacity, in that case it may lead to a loss of P minus D. Now, if demand is less than equals to B minus C, the probability is G B minus C, this is the probability, and demand will be greater than B minus C, this will be the probability with 1 minus G B minus C. So, these are also the probabilities. So, in this way you have a decision tree for developing this entire scenario, that if I am going to book one extra seat, what will be the different possible impact in marginal revenue case. Either there will be no impact, or there will be a impact of extra revenue by one extra customer, or there will be a possibility of loss of P minus D. So, these are the three possibilities which may happen in case of booking the additional seat. So, the total marginal impact will be the impact multiplied by corresponding probabilities, that will be the total marginal revenue, expected revenue for increasing the seat from B to B plus 1, and that is the decision rule. Now, for simplifying, rather going deep into the mathematical calculations, in fact you are welcome to do this calculation, that this probability multiplied to this case, this probability, and then this probability multiplied by this, and then this multiplied by this, that is in fact 0. That is our expected revenue from this particular scenario. So, if I simplify this particular case, so the practical way of implementing this whole risk based policy, that we initialize B equals to C, the booking which we are going to accept that is equal to the capacity of our servers. Now, whether you are going to take additional seat, that is C plus 1 or B plus 1, same thing. Now, what is the optimal number for you to decide that this becomes our decision rule? This relation, the development of this relation is coming from this decision tree only. So, rather going into the mathematics, we are directly coming to the use of this particular decision rule for us. So, you need to calculate these two terms. One is P by D, P is the price, revenue, and D is the cost of denied services, and that is one ratio, and you have to compare this ratio. This, let us say, for the benefit of all, this is price divided by cost of denied service. So, this is one ratio, and you have to compare this with probability of demand is equal or less than B minus C. So, you have to see these two comparisons, price upon cost of denied service and probability of demand is equal or less than B minus C. Now, if left hand side is less than equals to right hand side, you stop, and the current value of B is optimal. Whatever is your current value, and the current value of B in this case is our capacity of the system. But in case left hand side is more than right hand side, then you can increase set B to B plus 1, and then again you can go to step 2, and with this iterative manner you can reach to that level where you will get finally the left hand side is less than equals to right hand side, and that will be the optimal value of B. So, that will decide that how much overbooking you can do in this particular case. So, after implementing this, this will get you the smallest value of B, the smallest value of B for which P by D, the left hand side, is less than equals to probability of demand being equal or less than B minus C. So, in this case we will see that the implementation with the help of a very simple example, and this example gives you this implication of the rule we discussed. We are considering a flight with 100 seats, the fare is $120, and we have given you the cost of denied boarding, that is $300. Now, in this case P by D, that is 120 by 300, that is 0.4. Now, assume that no shows follow a binomial distribution with P equals to 0.42 and N equals to 20. This means that the expected number of no shows is 8.4. Now, the probability G B minus C is then as shown in the third column of the table, which is there on our next page. So, these are the different levels of B. You see the capacity of the aircraft is 100. So, we are starting B equals to C. So, that is B equals to 100, that is the starting point, and you see our column number 1, that we are doing increment of 1 with every step. So, B minus C is 0, and then the probability, the difference of demand B minus C is 0 or less, that is coming with the binomial distribution, and in this case the passenger revenue and all other cost etcetera and the expected net revenue are calculated in the further columns. Now, if I increase the 100 to 101, 102, 103 and keep on increasing one by one, at 108, when B minus C is 8 and the probability is 52% that the difference of booking and the capacity is, the probability is 8 or less than 8, that probability is 52%. The passenger revenue is coming 11,952 and the expected cost of denied boarding in this case is 204 and expected net revenue is 11,747. That is the highest in this particular table, and this will give you a very good idea that if you see in the form of a graph, that as you are booking, let us say this is your capacity 100, as you are going up to 108, your revenue is increasing, expected net revenue, and after that your expected net revenue is declining. So, as you are further increasing your capacity, your expected net revenue is declining. However, you see interesting thing is, as you are continuously increasing your, so let me have this. So, this is total revenue, this is also total revenue, but this is net revenue. That means your net revenue will start declining after a particular time and your total revenue may still increase, because you see that this is continuously increasing, but because of your cost of denied boarding started playing important role from this point onwards, or let us say from this point onwards, and therefore, your net revenue started declining from this point onwards, and this is the highest net revenue, that is 11,747. So, before that, therefore, if you see up to this point 11,352 and 11,351, your total revenue and net revenue are almost similar, but as you are going for more overbooking, now there will be chances of some denied boardings. So, therefore, the cost of denied boarding started appearing. It was almost negligible before this level, and as you are going with higher and higher overbooking, the cost of denied boarding will also become significant over a period of time. So, therefore, in this particular scenario, going by this table, we see that the 11,952 is the level at which you should have the passenger revenue highest. Now, without going for this entire calculation, this is not needed. This is just for showing you that how things are happening. We just need to calculate this column. This is the important column. Our probability of P by D, the ratio is 0.4. Now, in this column where we have the probabilities of B minus C, that how much overbooking we have done, after 0.35 we should have the label equal to 0.4 or immediately higher label than 0.4. So, after 0.35 the next value is 0.52, which is higher than 0.4. So, this becomes our optimal label of overbooking. So, these 4 columns which are there to just justify that the label at which we are correcting our overbooking, that the overbooking of 8, how it is leading to highest level of expected net revenue. So, in our all practical purpose on a very fast move, you need not to go for all these remaining calculations, you just need to know that what are the values of G, B minus C probabilities, like in this particular case it is given with binomial distribution. Maybe it may follow some other distribution also. So, accordingly you may check that what should be the probability, and accordingly you will see that this is the overbooking number. Now, in the same case, if I have a different aircraft, let us say 120 seat aircraft. So, I will start this B with 120. If my aircraft is a 120 seater, so my table will start with 120 and I will do the increment of 121, 122 and so on, and in that way I will find that what should be the optimal level of my overbooking same way. So, this B minus C will also be same way, that is because now it will be 120, 121, 122, 123 and so on. So, this will be 128. So, the difference of B minus C will always be the same, because the increment is happening only of 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on. So, this probability function will also give you the same value all the time like this. So, in a way, whether it is a aircraft of 100 seat, whether it is a aircraft of 120 seat or whether it is a aircraft of 200 seat, I will always go for overbooking of 8 seats in this case. So, the capacity of starting is not the point of deciding the overbooking. The overbooking is basically coming with the ratio of P by D. That is the most important factor for deciding this particular case, and in this way we have seen that yes, in this case the passenger revenue, the expected net revenue will change, because now more passengers will be travelling in the aircraft. So, that revenue will change, but what will be the amount of overbooking, that will remain same irrespective of what is the size of your aircraft. So, this is our risk based policy. I hope we understood it very well. Then another policy is the service level policy, and in the service level policy we are going to do the overbooking in such a manner that we should give minimum number of denied boarding to those customers who are coming to avail the service. So, here our idea is that we should provide maximum level of services to all those customers who are coming to avail our services. That is the service level policy, and in many cases customers are preferring the service level policy over the risk based policy. The reason is goodwill. So, when a customer has actually come to your point of service and you are denying the service to that particular customer, so the creating upset mood of the customer or creating the loss of goodwill is a bigger loss for the company. So, therefore, and in the service industry, service itself is the most important criteria. So, most of the organizations are now preferring the service level policy over this risk based policy, because risk based policy is more profit oriented kind of policy and less service oriented policy, and in the present environment people prefer more service orientation than the economic or monetary issues. So, this particular thing is more used. The second important point which is in favor of service level policy, that risk based booking can lead to wide variations in booking limits and potential number of denied boarding from flight to flight, and this will lead to bigger challenges, that if more you can say denied boardings are happening, this will create lot of challenges for the operators, and that may lead to some kind of situation which is not desirable, and it is going to lose the confidence of customers in that particular services. So, organizations want to become more service oriented. Now, in the service level policies, we generally have this issue that how we are going to book that level of services where we are leading to less number of denied booking. So, in this case airline is setting a policy that a fraction of booking that results in a denied boarding should be approximately 1 in 10,000. Generally, this rule that what should be the number of denied boarding in your particular case is based on the industry standards. So, there are benchmarkings available, and based on that benchmarking you may decide that what should be the number of denied cases in your particular case. So, it may be different for hotels, it may be different for airlines, it may be different for car rentals and so on. Now, in this case a term SB refers to shows given booking limit B. So, S, as I have already explained, is the number of customers who are actually appearing, and the B is the booking limit, and C is the capacity of the particular server. So, in this particular case, the way of setting the B, what should be the B, is expected numbers of SB minus C, and again this is only 0 or positive values are taken, that is the meaning of this plus superscript, with ratio to expected number of shows, particularly with respect to booking limit. So, this you are setting as 1 upon 10,000, out of 10,000 customer you are allowing only one denied services. Or in the simple way, if you do the mathematical jugglery, you will find this relations, and in this way you are having a policy which would specify that the number of denied service incidents should be some specified fraction of customers served rather than the total number of bookings. This is the way in which airlines report denied bookings to the Department of Civil Aviations, and as we just mentioned that Osaka Airlines experienced 0.81 involuntary denied booking boardings per 10,000 passengers in year 2003. So, the number that 1 out of 10,000 you can say is very close to this Alaska's achievement, that 0.81 out of 10,000. So, under this policy the company would set B so that this left hand side expected value is equals to Q into E, that is the target denied service fraction, like in our case it was 1 upon 10,000, and this is the expected sales given a booking limit of B. So, in this way you can operate your service level policies also. Finally, organizations want to take the benefit of economies also, and also they want to minimize the cases of denied services. So, therefore, nowadays organizations are developing a combined policy which is known as hybrid policy. So, where we are trying to minimize the losses because of overbooking of cost of denial of these services, and we are also looking that how we can minimize the cases of denied booking in terms of fraction of customers who are appearing for availing these services. This is known as hybrid policy, which is more complex in nature, and it will be difficult for us to discuss those policies in the form of a course which is more using the modern methods of AI and machine learning, that how you can combine these two policies for getting the benefit of both the systems. So, with this we see that the deterministic policies are easiest to implement, then risk based policies and service level policies are other two policies which are popular, and the hybrid policies are in the development where we are combining the economic benefits as well as the benefits of the service labels. With this we come to end of this particular session. Thank you very much.